In number 12, we're asked for x equals -6, which inequality is a true statement. This just requires that we replace x with -6. So let's take choice A, and let's replace x with -6. Doing the arithmetic on the right side, -3 plus 30 is less than -14, and -3 plus 30 is 27. Is 27 less than -14? That is not a true statement, so we can get rid of that one. Now let's take a different inequality. In choice B, we have 1 minus 2 times x is less than 13. So 1 minus 2 times -6 is less than 13. -2 times -6 is positive 12, so 1 plus 12 is less than 13. 13 is less than 13. That's not true. 13 is equal to 13. Now let's look at choice C. -5 minus 3 times -6 is greater than 10. -5 plus 18 is greater than 10, and that gives us 13 is greater than 10, and that's a true statement, so that one will be a correct answer choice. We can also test choice D, which gives us 2 minus -6 is less than -3, and 2 minus -6 is 8. 8 is not less than -3, so that's not a true statement. For number 13, we're asked to solve the inequality. So the very first thing I'm going to do is distribute the multiplication. 15 minus 3 times x is less than -2x plus 6. And next, I'm going to add 2x to both sides. So adding 2x, 15 minus x is less than 6. And now subtract 15. So subtracting 15, -x is less than -9. And I believe I've made a mistake here, so I'm going to change something. When I distributed, was careless about the distributing here. This is the nice thing about multiple choice, right? It's a little forgiving because we can get to a place and realize that we've made a mistake. So 15 minus 5x, when I distribute, is less than or equal to -2x plus 6. So now I'm going to add 2x to both sides, and then subtract 15 from both sides, and now divide through by -3. When I divide by -3, the inequality changes directions, and then we get x is greater than 3. In number 14, we're asked which of the following inequalities has all real numbers as its solution. Let's try choice A. So distributing 5x plus 20 is greater than 5x plus 20. If we subtract 5x from both sides, we get 20 is greater than 20. That's not a true statement, ever. So that means that this does not have all real numbers as its solution. All right, now let's solve choice B. 7x plus 2 is greater than 3x plus 2. I'm going to subtract 3x from both sides. Now we have 4x plus 2 is greater than 2. And now let's subtract 2 from both sides. And then we've got 4x is greater than 0. Dividing by 4, x is greater than 0. This has a solution, but only for values of x that are greater than 0. So the solution is not all real numbers. So we can cross this one off our list. Now let's attempt to solve choice C. Distributing 6x plus 6 is greater than 6x plus 2. Subtracting 6x from both sides, we get 6 is greater than 2. In my experience, 6 is always greater than 2, so this has a solution of all real numbers. Let's take a look at that last answer choice. Distributing 4x minus 12 is greater than 4x. When we subtract 4x from both sides, we get negative 12 is greater than 0. That is, in fact, never true, so it has no solution. All right, in 15 through 16, we are using the third number line to graph the intersection of the other two. Intersection is what the two have in common. In other words, where's their overlap? The overlap for the two number lines in 15 is that portion in between those two numbers that they have in common. Doesn't include negative 4 because that's not common to both. It's only in the second number line. Positive 1 is filled in or shaded in both number lines. Number 16, the intersection, what they share in common is everything 1 and to the right. That's the overlap between the two. All right, in number 17 through 18, we are graphing the union. The union is the joining of the two sets together. So if we graph everything that was graphed in either the first number line or the second line, everything that's shaded in either one of them is that region from 3 to the left. In number 18, we shade anything that was shaded on either of the two number lines. We get what's called a disjoint set. Disjoint sets can only be stated in simplest form with the word or. All right, in 19 through 27, we are matching each equation inequality or compound inequality with the graph of its solution set. So x is greater than negative 1 or x is less than 1. This is an or statement. So if you want to look at three number lines, and include negative 1 and 1 on those number lines, our first number line would include x greater than 1. Second one includes x less than positive 1. The word or implies the union of the two sets, which would be everything shaded. So in number 19, we're looking for the entire number line shaded, which is choice R. In number 20, we have an equation, the absolute value of x is equal to negative 1. There is no number that makes it true. That's not true. Nor is the absolute value of positive 1 equal to negative 1. An absolute value can never be equal to a negative number, and so therefore this has no solution. So we are looking for the number line that has no shading on it. The number line that has no shading on it is choice N. For number 21, x is less than negative 1 and x is less than positive 1. We can make three number lines. And I want to put negative 1 and positive 1 on those number lines. On the first number line, we're going to graph x is less than negative 1. On the second, x is less than positive 1. And we're joining with the word and, which implies the intersection. So that would be everything to the left of negative 1, which corresponds to choice H. For number 22, the absolute value of x is greater than or equal to negative 1. When we're comparing an absolute value to a negative number, I want you to think about it this way. We are looking for where a positive number, or 0, is greater than or equal to negative 1. Any positive number or 0 is always greater than or equal to negative 1. So this has a solution of all real numbers. All real numbers is the entire number line shaded, so that would be choice R. In number 23, we have another AND statement. So I'm going to draw 3 number lines and mark off -1 and +1 on those number lines. First number line, x is less than or equal to -1. Second number line, x is greater than or equal to +1. We're joining with the word AND, which means we're looking for what they have in common. And they don't have anything in common, which means that the solution for this one is no solution. We're looking for the empty number line, which is choice N. Now let's take a look at number 24. For number 24, the absolute value of x is less than or equal to 0. So we are looking for where a positive number or 0, because the result of an absolute value is either a positive number or sometimes 0. So when is a positive number or 0 less than or equal to 0? Well, a positive number cannot be ever less than or equal to 0. But 0 can be less than or equal to 0 because it can be equal to 0. So what is the only number that makes this inequality true? 0 is the only solution, so we are looking for a single point on the number line, x equals 0, and that would be choice M. For number 25, the absolute value of x is equal to 1. The numbers that make this true are 1 or -1. So we're looking for 2 single points on the number line, 1 or -1. That would be choice P. Where am I? In here somewhere. There we go, choice P. Number 26, the absolute value of x is less than 1. An absolute value less than a positive number is equivalent to x is between that positive number and its opposite. So we are looking for on the number line the graph that goes from -1 to positive number 1, not including the endpoints, and that would be choice I. For number 27, the absolute value of x is greater than 1. This is equivalent to x is less than -1 or x is greater than +1. So we are looking for a disjoint set. And that disjoint set would be choice K. For number 28, the absolute value of x is greater than 0. So again, think about the output for an absolute value can either be positive or it can be 0. So when is a positive number or 0 greater than 0? Well, in this case, a positive number is always greater than 0, but 0 is not greater than 0. So in this case, any number works for x except 0. So we are looking for a full number line with just 0 excluded. That would be choice Q. For number 29, we have another OR statement. And so I'm going to draw 3 number lines, rather. Let's see if we can make this bigger. So I'm going to mark off -1 and +1 on those number lines. And x is greater than -1 on the first number line, x is greater than +1 on the second, or implies union. So we are looking for what the two have when they are joined together, or when we shade everything that's shaded in both of those sets. And so we are looking for the number line that starts its shading on the right of -1, and so that would be choice F. And last one is an AND statement. I'm going to draw number lines for this one as well. and we'll shade x is greater than or equal to -1 on the first number line, x is less than or equal to +1 on the second. We're joining with the word and, so that's what the two sets have in common. So that would be the region in between -1 and +1, including both endpoints, and that is choice J.